Good afternoon. I'm Gene Ellis. I'm an old retired engineer from Slower, Lower Delaware. I got interested in Earth expansion after retiring, trying to fit in some of the missing pieces.
Okay, I'll help you. You need to go to the next slide? You got it.
Donald Rumsfeld once remarked, reports that say something hasn't happened are always interesting to me because, as we know, there are known knowns. There are things we know that we know. There are known unknowns. That is to say, there are things that we know that we know. No. There are things we now know that we don't know. But there are also unknown knowns. There are things we do not know, we do not know. Missing is unknown knowns. Things we don't know that consensus says we do know. Consensus says matter is unchanging. Atoms cannot change size. Consensus says the ocean floor is subducting. Less dense matter is piercing more dense matter to recycle in the mantle of a constant radius Earth. In the universe, all matter that matters consists of elemental atoms. We can see most elements, but not their atoms. All elements are different from one another, as are their atoms. We think we know much about ionization, but we don't know when it begins or all that it does. We don't know what we don't know. In 1970, Charlotte Moore compiled and published MBS 34, ionization potentials and ionization limits derived from the optical spectra. Table 1 of MBS 34 indicates normal matter is detectable and identified in the spectrum and lists the IP for each element. This is a copy of MBS 34. These are the first 30 elements from that publication. Ionization potentials are energy levels in electron volts when an element has the potential to join other elements. It's more or less a chemical definition. Much can be gleaned from this table of ionization potentials. First, the energy is contained within the element. Reading the chart from left to right is reading it from present to the past, and from right to left is reading it from the past to the present. Notice the small incremental change jumps between the IPs that suddenly become large jumps in the highlighted areas. This anomaly signifies something different is occurring. The first time an element ionizes, it becomes normal matter and its intrinsic energy begins to decay. Exceeding the highest IP for any element indicates such element is undetectable and exists as dark matter. Presently, all the elements have ionized Hence, there is no remaining dark matter when considering all matter in the universe consists of elemental atoms. Additionally, these ionization potentials provide the data for finding an energy rate of decay by utilizing the atomic mass, the quantity percentages of the mixture, and an exponential doubling equation y to the x equals 2. This method was discussed at the CMPS 2016 conference in College Park and can be found on the first 2 pages of the IONIC drawing Earth paper on my website. Decay rates of Earth, Moon, and Sun. There are 8 elements that make up 98.8% of Earth's matter. The first 4 make up 93%, and the last 4 make up the difference. On Earth, 1 electron volt decays every 1.6 million years. There are 6 elements that make up 99% of Moon's matter. The same elements that the Earth possesses, except for sulfur and nickel. Now, of course, different percentages of all. On the Moon, 1 electron volt decays every 2.0348 million years. There are 5 elements that make up 99.57% of the Sun's matter. Helium and hydrogen make up 98.1% of that. On the Sun, 1 electron volt decays every 8.29 million years. If you multiply all the IPs on Charlotte Moore's chart by Earth's decay rate, it will give you the time of occurrence of those IPs. Calcium was the first element to ionize 8.8 billion years ago, and hydrogen was the last around 22 million years ago. When you plot the IPs of the 8 Earth elements using red for the anomalies, you get this figure. This is over a 4.5 billion year period. Here, the anomaly identifies the origin of heat. Heating that was necessary to melt the 32.1% iron, almost a third of the Earth's matter, that gravitated to the core of a smaller Earth. The same 8 elements that started the Earth heated the Earth for the first 3 to 3.5 billion years. This changes everything we think we know older than 700 or 800 million years. The origin of water occurred when oxygen ionized for the first time. That would be around 1,400 million years ago. The first ionization energy of oxygen was 871.38, and when you multiply that by 1.6, you get around 1.4 million years ago. That was the first water. The origin of hydrocarbons is around 800 million years ago, and life depends on the hydrocarbons and oxygen, so the origin of life began around 800 million years ago. Knowing when the basic elements can ionize and join other elements, life on a rocky planet swimming in water 3 billion years ago remains unchallenged and believable. Radiometric dating is not reliable for dating ancient rocks because it does not consider, I lost my place. Jeez.
Go back, sit right there.
There it is. Radiometric dating is not reliable for dating ancient rocks because it does not consider when the rocks were in a molten state. It should because no one could know the composition or the location of molten rocks 1 billion or 2 billion years earlier. These charts indicate that most of the growth on Earth, the Moon, and the Sun occurred within the last billion years. These are the calculation tables of the Earth, Moon, and Sun that basically deducts the heating phase to obtain the resulting growing mass. The X column, log 2 over log Y, is the mass doubling time for the years in the first column. The Earth is currently the Earth's current doubling rate is every 49.5 million years, while the Moon's rate is around 40.7 million years. The Sun is doubling its large mass every 16 million years, or 3 times faster than the Earth, while the smaller Moon is growing faster than the Earth. The left half of Table 5 for each, the Earth, the Moon, and the Sun, is set as essentially Table 4R. The right half results when the increasing radius follows the increasing mass by 100 years. The volume increases always lag the mass increases. Graphs of Table 5 for Earth and the Moon. Some interesting points are surmised when comparing the size of Earth from James Maxwell's book, Beyond Plate Tectonics, with the IONIC growing Earth data. When the radii are plotted, as in this chart, it is noted that the difference in size until 250 million years ago can generally be attributed to the growing continents, since the expansion tectonics model only closes the oceans. A halving of the radius, or gravity, is indicated as 50%, 175 million years ago for the ionic growing Earth, and 240 million years ago for the expansion tectonics model. The differences between 250 million years ago and 600 million years ago are likely due to the size of the primordial radius, 1,700 kilometers versus 800 kilometers, and a time when exponential expansion effectively began. A second halving of the radius is indicated on the IGE curve at 25%, around 470 million years ago. A second halving is not possible with a 1,700 kilometer primordial radius. The 2011 Nobel Prize in Physics was awarded to Saul Perlmutter, Brian Schmidt, and Adam Rees for, I quote, the discovery of an accelerated expansion of the universe through observations of distant supernovae. The yellow arrows indicate when the accelerating expansion began on the Earth around 200 million years ago, and on the Moon around 250 million years ago. This graph indicates accelerating expansion started on the Sun around 110 million years ago, when the 71% hydrogen began to grow. During that 110 million year period, the Sun's radius doubled twice, once at 25%, around 105 million years ago, and again at 50% around 70 million years ago. The Sun's radius also doubled at 12.5%, 300 million years ago, and 6.25% around 370 million years ago, when the 27% helium was growing between 203 and 451 million years ago. I lost it again.
Go back 2 screens.
Did I jump?
Yeah, go back 2. There, right there.
The three minority elements are responsible for all growth between 112 and 203 million years ago and prior to 450 million years ago. Doubling the mass 3 times will double the radius once, resulting from an 8-fold mass increase. Doubling the mass 6 times will double the radius twice, resulting from a 64-fold mass increase. Doubling the mass 9 times will double the radius a 3rd time, resulting from a 512-fold mass increase. This thing moves too fast for me. I lost it
Go
again.
back 1. There.
Doubling the mass 12 times will double the radius a 4th time, resulting from a 4,096-fold increase. The above graph indicates the Sun radius doubled 4 times in less than 400 million years. The overall mass curves are exponential in nature, but the doubling rates between the points do not change, therefore are linear as shown. The oddity of the Sun's graph when compared to the Moon and Earth graphs is due to the break between the helium growing time and the hydrogen growing time, when there was very little expansion occurred. This break punctuates and changes the continuity of a curve that employs the identical exponential doubling technique for the Earth and the Moon. Similar punctuated expansions will occur on stars and other celestial bodies predominantly composed of hydrogen and helium. The mechanism for growing matter is the same mechanism that affects energy converting to mass in the equation E equals mc squared, except on a micro scale. Observing the photon is an example of pure energy at a higher level transforming to additional mass at a lower level. A change in thinking about matter is long overdue. Everything in the observable universe changes with time. The problem of growing matter stems from a 13th century premise that the essence of matter is unchanging. Today, that assumption in the scientific world has become a certainty, meaning atoms cannot change in size or numbers. That certainty leads to confused thinking when considering the interchangeability of energy and matter. If one truly believes that atoms of matter cannot change size, then what is the energy converting to in Einstein's famous equation? Aging causes inherent elemental energy to decay, and decay involves a conversion process. Finding the rate of decay, which is dependent upon the elemental composition amounts present on a celestial body, allows knowing the time when the elements of such celestial body ionize and when they are growing and when they are not. Growing old is the reason elemental atoms at certain times are growing larger, and ionization is an integral part of such mechanism. Increasing the amount of a substance does not increase its density, rather it increases the mass. Growing matter utilizes this intensive process, hence density remains nearly constant, only allowing for compression within a celestial body until the pressure is relieved and the volume expands. Volume increases always follow mass increases. Growing matter increases mass, not density. Gravity is not too much concerned about volume, but it is concerned about mass. Quantifying additional mass using the leap second data from Wikipedia. Between 1980 and the end of 2016, there were 18 leap seconds in a 36-year period, averaging 1 leap second every 2 years. Thus, 1 leap second per 2 years equals 0.5 over the number of seconds per year, which is 1.5844 exponent minus 8. Therefore, the amount of mass required to slow the rotation of Earth's present matter by 1/2 leap second with no change in the angular momentum is the present Earth's mass, 5.98 exponent 24, times the above number, and you find 9.47 exponent 16 kilograms per year. This amount translates to the energy of around 3 million electron volts per second, converting to around 3.3 million tons of mass per second. Every second that goes by, 3.3 million tons of additional matter is added. The leap second represents a slowing of Earth's rotational spin, rotational velocity, which is spin. Current mathematical model was derived from length-of-day work by Stevenson and Morrison, and is based on a solar day equal 86,400 seconds. This model wrongly attributes the slowdown to tidal friction and possibly a redistribution of Earth's internal mass, all of which presume a constant mass with some questionable transference of energy and momentum to change orbital motion. Jack Honor, on page 15 of his paper, Deficiencies in Tidal Friction, calculates 5.685 exponent 16 kilograms per year mass increase while conserving angular momentum by using a completely different method. You physicists and mathematicians would be interested in that. This compares favorably to the 9.5 E16 calculation using the lead second and a 7.35 exponent 16 kilogram calculation from the Growing Earth paper. The Kelvin units of CVR says it is measuring temperatures 2.73 degrees above absolute zero, which would be the average temperature of the vacant spaces in the atmosphere, and not a remnant of a Big Bang. The reason this number is so low is because mass is growing at a much faster rate than all the heat generated from all the stars and elsewhere, thereby diluting temperature increases. The entropy of the universe is increasing while its temperature is diluting by the increasing space. The red arrows pointing to the last column are percent heating, indicate an extensive heating period between 358 million years ago and 241 million years ago that materially intensified for the 25 million year period between 266 and 241 million years ago. In light of today's global heating debate, where a few degrees rise in temperature in a few decades or centuries is considered highly detrimental to life by many, envision 25 million years of increasing temperatures and its effects upon all life on the planet. Coincidentally, the intensified heating culminated near the Permian-Triassic boundary 250 million years ago, the geological time of the world's greatest extinction. Consequently, geologists should consider excessive heating as a cause for that event. Some recent studies indicate cellular mitochondria produces temperatures of 6 to 10 degrees centigrade above skin temperature. The conventional answer, converting chemical energy from food to ATP, does not address the origin of the heat. Presently, two vital elements for human life, sodium and potassium, are in the heating phase. Is it possible that heat is being extracted from those two elements? I don't have a physical chemistry answer, but it's something to think about when the decay energy of one electron volt is equivalent to producing 11,604.5 Kelvin temperature. Of course, that's over a 1.6 million year period. Reduced gravity on a smaller planet permits larger life sizes, but does not explain the gigantic dinosaurs of the past. The largest recorded land creature today is a 12-ton elephant killed in 1956. Accordingly, the largest life size permitted with a 50% reduction in gravity, say 175 million years ago, would be a dinosaur weighing 24 tons. How is that possible when the biggest dinosaurs are reported to weigh 70 tons and lived 100 million years ago. Gigantic sizes appear to be possible because we are finding and measuring dinosaur fossils and not considering the minerals that replace the organic dinosaur bone substances. The fossil minerals are from the same matter that produced an 8-fold mass increase in 175 million years. Growing matter allows and limits larger past life sizes, thereby negating the dinosaur paradox. Fossils are rocks, and the rocks are growing. Everything in the observed universe is changing. Subscribing to a theory of everything changes does not negate or denigrate theories based on unchanging matter, or theories based on unchanging time, or quantum mechanics, which is consistent with the Standard Model and special relativity. Changes and adjustments are inevitable when the assumptions are revealed. The merits of each can coexist like mathematical trains running on different gauge tracks. Summarizing, we covered the ionic growing sun, earth, and moon, known, unknown, known, and consensus, when dark matter exists, the origin of heat, water, hydrocarbons, and life, when the element first ionized, Earth's mass was heating for the first 3 to 3.5 billion years. Radiometric dating of rocks over 1,400 million years ago is false. We showed when the accelerating expansion began on the Earth, Moon, and Sun, demonstrated the Sun's mass increased roughly 4,100-fold in less than 400 million years. When accelerating expansion begins on the Earth, Moon, and Sun, the stars experience punctuated expansion like our Sun that began less than 500 million years ago. The expansion mechanism, energy converting to mass, per Einstein. Density is unchanging except for compression. The leap second quantifies the atom mass. CVR is the average temperature of the vacant space in the uniform. Global warming likely caused the mother of all extinctions, debunked the dinosaur paradox, and indicated a possible mitochondria heat source. Thank you.
Okay, we have some questions. I have a question. One of the things I have thought about with expanding Earth expansion tectonics or growing material is you have the fight between fossils, the rocks themselves growing. You can hear me?
Yeah, but
Okay, can you hear me if I, this loud? Can you hear me?
go ahead.
All right. The fight between the rocks themselves growing and the Earth being smaller in mass. You're right, the Earth was smaller in mass by half the size, more or less, when the dinosaurs were roaming.
The radius of the Earth was approximately half.
And what about the mass, according to your calculations?
Well, the mass would be 1/8 of the present mass.
And then, have you read Stephen Hurl's book?
Yes.
And so how, this is an interesting thing I have also thought of, the idea that the bones are growing in size versus that the dinosaurs were actually in a smaller gravitational field. Both. So you subscribe to both?
Yes.
Okay. Another question I have is the size calculations that you had for the sun, the changes. Is that your calculations or is that commonly known?
It's not commonly known. That all came from doing the Earth and then similarly doing the moon and transferring it all to do the sun, just knowing what the basic elements that compose each of those.
Okay, so if I understand, it's just looking at what elements are composed and how they are reacting to their half-lives and also gaining mass.
Yes.
Okay.
And it's different for each place.
That's because of the composition, also the chemistry that's going on, right? Because
it's mostly the quantities involved and the elements. The smaller the elements means it's going to have a longer decay rate.
okay, okay, thank you. Any other questions?
Yes.
Very, very interesting. Talk of millions or billions of years ago, the period of revolution of the Earth. That's 1 year now. Well, is it the same as it was a million years ago?
He's asking, is the period of a year today different from than in previous times?
Yes. The year is getting shorter. And by over the last 36 years, it got 18 seconds shorter. And this has been going on previous times also.
Is this a linear thing or is not?
Is it?
Is the change of period in the year linear or a different function? Is it changing at a steady rate or at a...
It's changing by the amount of mass that is accumulating every year.
Okay.
And since the accumulation is exponential, it's increasingly affecting a year's time.
Okay. Another question? I think we have one from the internet. I think I'll do it here. How can so many different theories be all correct at the same time? We are all blind, feeling the different part of the universe elephant. I think what he's saying is that there are different ideas and explanations for expansion and different ideas. I would imagine there's people think that the Earth's hollow, they think it's more chemical, some people believe it's at the atomic scale, that it happens at the subatomic scale, some people believe it's the mass coming in from outer space. How do you see, because you've been in this quite a while, what do you see with all those different things fighting? What's your observations?
I went along with a lot of those observations until I found that the growing elements fit the bill best. And it didn't fit it until it was discovered, the anomaly, and taking that time out, then all the pieces came together. And the time is very close to what the geologists put out up to around 600 million years ago.
So you have worked closely too, if I understand, with James Maxwell?
Yes.
And you consulted him for what?
Initially I consulted with him on the expansion things, that he was writing the book at that time. And he gave me some chapters from previous book and some chapters from a paper he presented in Maryland. And from that, we emailed each other, and I had questions, and he had questions. And
so what is James' take on your work?
I don't know. He sort of went with what Carrie was promulgated but couldn't find. I think I mentioned once to him, if Carey knew that the elements could grow, I think he would buy that theory.
Okay, all right. Any more questions?
Yeah, so initially you had started out with this ionization chart, but I'm still not quite sure I understand what is the mechanism by which your atoms can grow. Does that have to do something with the ionization? How did that work?
He's asking, does the mechanism for growth have to do with ionization and how that works?
The ionization tells you when these events can happen. The energy, it tells you the energy level of an element when it can join other elements. And the first time it ionizes is it acquires the potential to join other elements. And the clock starts running on aging. So every 1.6 million years, you lose 1 electron volt. And that applies for each element. Does that answer your question?
No, it doesn't.
Okay, well, maybe we can take that offline. Okay? Any other questions? Okay, thank you very much, Eugene. Thank you.